This is Larry. This is Leetcode day 24 of the Leetcode challenge. Let's get started. If you're watching this, hit the like button, hit the subscribe button, leave a comment on how you do. Did you like this farm? Was it fun? Oh, LRU cash. And let me know how you feel. So this is a very uh, this is a pretty standard both interview question, and actually doesn't come up that much in computer programming per se, but the idea still comes up. So LRU cache is a very well studied thing, but the idea is that you have a cache that you can only fit n items. Well, let me read this just to make sure, because sometimes they make changes. LRU cache, design and implement a data structure for a least recently used cache. It should support the following operations: get input. Get gets the value of the key if it exists in the cache, otherwise return -1. Put sets or insert the value of the key is not already present. When the cache reaches its capacity, it should validate the least recently used before inserting the new item. This cache is initiated with positive capacity. Can you do both operations over one? So this is a standard LRU cache. Um, I'm going to still try to solve it live. It's been a little bit of a while. But the idea is that you use a linked list, and whenever you need to cache and validate, you just um, either a linked list or queue, I guess, maybe. Well, a linked list makes more sense because a queue, you have to be able to take middle items and then put it on the back of the thing whenever you use it. And I think the only other question that I might have is is it doesn't define what is most recently used, or like what counts as recently used, meaning does get updated used, does put updated used. Sometimes some even could, yeah, sometimes they do, sometimes they don't. So I'm not super sure, but we'll discover as we come out. But yeah, let's kind of get started. I think this is kind of straightforward-ish. Um, okay. Yeah, so let's just do self.capacity is equal to capacity. Let's write a linked list node to help us. Uh, what's in the node? Let's see. Is it just the value? Uh, let's just start with the value. I think in theory you could also like keep track of the last time it was accessed or something like that. But for now, let's just use the value, and yeah. Okay, so that's actually also, what do we want to do? Hmm. So yeah, so for linked lists we have both a head and a tail. Actually, I have been usually what I would write is something like this, and then we would have to, and actually maybe let's abstract it away, right? Linked list is equal to linked list. Say, oops, list. And then let's abstract it away. What do we put? Okay, so now we do self.head is equal to none, self.tail is equal to none. So actually, I do want to try something new here, so bear with me a little bit. I think this is let me know if, in the comments if you want to elaborate a little bit. Maybe I'll elaborate a little bit more. But I do want to play with this linked list implementation that I didn't actually learn when I was starting out. But this idea of a sentinel value, um, so that it because otherwise you have to check a lot of nuns in a lot of cases. So I think I'm gonna try to do that. Yeah. So sentinel is equal to node, say none, and then yeah, sentinel dot. Oh yeah, I forgot. I was like, what else do you need from a linked list node class? How about a next? So I'm actually going to do a double linked list versus a single linked list, so that some of the other operations becomes a little bit easier. Uh, I think in terms of complexity is about the same. I mean, the complexity is definitely the same. It's just, yeah. So now I'm going to try to learn this new way of doing it with Sentinels. So I might have run into some issues, but um, yeah, you're going to watch an old dog trying to learn a new trick. So bear with me, and also hopefully this is a little bit educational in that sense. Okay, so let's try that first. Link list, link list. Okay, we have everything we need, maybe. And then now we have the actual just cache, which we can use. Okay, let's just use a dictionary. We could use a default dictionary was what I was kind of maybe trying to think about, but that maybe complicate things a little bit. So get, yeah, if key is in the cache, then we just return key. Otherwise, return -1. Um, I like this the other way better. To handle the normal cases deeply. Then put is a little bit more interesting, right? So in some order, we definitely want to push. We want to set something like this, but so now we have to. Let's take a look. If the length of the cache is greater than capacity, then we have to erect. Is that true? Well, that's definitely true, but I think actually what we want is if the length +1 is greater than capacity because we're inserting something, right? Because I think we're supposed to invalidate first. Okay, yeah. So that means if also if you do the math, that means if this is true, then we erect. And how do you erect? Well, we just take self.linked list dot pop1 or something like that. I mean, we have to write this, so it's fine. And then, okay, so let's get the key of the front of the queue, and then we remove it from the cache. And then now we can set the cache with no good. But then now let's also insert push back. Maybe that's better. Just push. Because I think that's how you using qubit. That's fine. Okay, so that's mostly it. But obviously, we also forgot one thing, or I forgot one thing, uh, which is that I forget. Let's leave it to do for now because I want to implement the push and the pop one first. But to do, update update linked list for recently used. Okay. Okay, let's implement the pop one first. So pop one is so it's a set node next, right? Okay, yeah. That next. So that is the node that we're removing. Okay. If node is self.sentinel, or oops, used English name. If that's the case, then we return -1 maybe. I don't know if that's actually the best way to return. I think we should probably raise an exception, but let's just put this should not happen, at least in LRU cache, raise an exception later. Or like in production code, that's what I would do. I mean, I don't know the clean way to do these things in Leetcode per se, but that's like very weird context specific. And then now, okay. So now if the node is not sentinel, then we can set self.sentinel is equal to node.next, skipping this node, and node.next dot previous is equal to self dot sentinel, right? Okay, that should be good. And then the other one is node dot next is none, node dot right, node dot previous is none. I some don't I definitely made this mistake before where I didn't free the pointers or reset the pointers to 0, and then I spent a long time debugging because I end up using the pointers in another weird way, and that was a mess. So that's why I'm, even though I don't know if it comes into play this one, but I try to reflexively do that. Okay, so this should be good, except we have to return the node, at least the value of the node. So now let's return the value of the node. And then now we want to, was it push back or just push? Push value. I don't even need to do nodes here, right? That's right. Okay. So let's just say node is equal to node of value. And then self.sentinel.previous, which is the tail end of the thing. We could set that. Okay, let's just do, well, we could do it the other way first. Node.previous is equal to self.sentinel. Wait, is that right? No, that's not right. Sorry, node.next is equal to sentinel because you want the next, this is a new tail node, so you want to put it in at the end. Yeah, and then self.sentinel. So now at the end, you want that to point to node. And node.previous is equal to self.sentinel.previous first, and then set that is equal to node. Okay. That's right. Is that sufficient? Double check. Well, for the node, you keep the my right, my left, go to the previous tail, okay, and then okay, so that's roughly right. Yeah, and then now we have to update the thing. Let's just do self.linkList.update key. Oh, we have to keep track of one more thing then. I mean, I could keep track in the linked list, but because I don't keep track of the nodes here, that's fine. Okay. So now let's just have a node lookup. Let's go to Pinky. Whenever we push, we will solve that node lookup of value is equal to node. And also when we pop the front, we want to delete the self dot lookup of node dot value. Okay. So now we can add a move to the back function. Oh, I call it update. Okay, fine. Update is more of a name that's fitting for LRU cache, not really for linked list, so just say move to back. So what does it mean to move to the back in this case? And also, it's a little bit, like Leetcode is not always going to be reflective, just like an interview is not going to always be reflective of your code quality. But ideally, what I would do is write unit testing along the way. But these are kind of really, I don't know how to do in Leetcode per se. So, yeah. And I move to the back. So now you have the value. So node is equal to self.node lookup of value. Let's just assert that's true. Well, it's in. But if it's not, then I don't know. You just have a mess in your hand. Okay, and then now we just have to move it to the back. And what does move it to the back mean? Well, node.previous. We will set the node's previous is equal to node.next. Sorry, node.previous next is equal to node.next. Node.next previous is equal to node.previous. So basically it's skipping this. And then now, now that this is all the way at the end, node.next is equal to self.sentinel node.previous is equal to self.send to node.previous, and self.send to node previous is equal to node. And if you're eagle-eyed, you'll notice that there's some code duplication here, and you are right. And that's it. Yeah. Okay. So now let's run some tests. We wrote a lot of code. We have about 65 lines of code, and not sure how I feel about it. This is actually oh, did I write? Hmm, 62. Why is it putting in -1 as a key? Oh, it's popping the front and it's returning -1. Hmm. Must be doing something weird. Okay, well, let's look at an example first. Um, First we put a put, and then now we put a wait. Oh, we put a put. Wait. Yeah. So okay, so now when you do a get, okay, I actually don't know when this thing's happening. So let's add a maybe it's this thing because it's popping front in a weird way. All right, let's just change this to assert so that I don't have to check this. For now, because I might have, well, if that throws an error, something else as well. Okay, that means that's fine. This means pop front as well. Here, which is why I was returning -1. But is my push one? Yeah, my push is missing something. That's why. Okay, that's why. Because I am not, when you push to the back, what I didn't do is that this is true, but what we need is self.sentinel dot the previous next is equal to no. Okay. This, also that means that this is probably in that point, and that's why you want to try yourself. Do not repeat yourself, because then okay. Delete lookup table. What is the key? The key is none. No dot what? Oh, because this is this. That means it is the sentinel value. Why else would it be none unless I'm passing in something dumb? Let's comment that out for a second just to see where we fail. Maybe there's some other fundamental things about it. Yeah. Okay, let's print this out after we put. Okay, so after the first one, after the second one, and then after you get the get, And then after you put in you put 3, but this is clearly wrong. It doesn't even make sense that it is a key of 2. Um, hmm. Oh, I, I'm being dumb. I used the same variable in 2 places. So okay. So I just go to still. Gotta be careful. Uh, I feel like that there are there's some linters that would prevent you from doing that, but uh, okay. Yeah, I'm getting this non-lookup. So get is 2. If get is non-cache, then that should be working, right? All right. Let's see where we actually fail. Okay. Okay. So we do the get part. It shouldn't be in the cache at that point, right? Nope. Yeah. So now is putting the full 4. So I think there's something wrong with this prop front that remove the node, self dot send node. Oh, this is wrong. That's why. Okay. I think that's why there's some confusion. So we wouldn't send a send node because that doesn't make any sense. What we want is, so now you pop the front, so self dot send node dot next is you go to next. Oh, okay. It's a typo. That's why you test things and ideally you have unit tests for each of these functions so that's easier to understand. Okay. Are we confident about this yet? Let's see. To be honest, not super really, but today, because the input is actually really annoying to put in. Uh, but let's see, what else can we really need to do? Maybe just put another get. Now put another. But yeah, I mean, I don't. No, I mean, there may be more edge cases, but it's really hard to kind of put it in. So, for the sake of kind of being lazy and time's sake, I'm gonna try submitting this and then see how it goes. And then yeah, there is a wrong answer. That's kind of good, because uh, that's why you gotta test these things in general. Let's see. So you set the cache up to 2. You put a get of 2. You put 6 in it. Uh, okay. Just want to make sure that that's why. But with 6 in it, okay. You get the 1, okay. Well, 1 doesn't exist. You put the 1 in it, okay. And you put the 1 in it again, okay. Uh, hmm. Maybe that's why. Yeah, I mean, I think the phrasing here is way not careful, maybe. I mean, I guess it makes sense how, I mean, I think so. So what's happening is that with this test case is that if you're doing a put on a key that's already in there, do you invalidate the thing first, or do you invalidate the last object in there? And I was gonna say I don't know. I think my code is technically right by this phrasing, but you can interpret it different ways. So I think that's because whenever it's at because it's literally right when they say whenever the cache reaches capacity, it should validate before inserting a new item. I guess you could also say that maybe it's not count as a new item. Okay. I mean, like I said, I could buy any of these interpretations. It's just that I interpreted one way, where it's not the case. And also, like for example, um, I think the other, and I kind of this question is if it sets the key, does it update the key? It's not super clear to me. Uh, but I guess we'll just use the system test to test because yeah, there are a lot of things we can put in, and I don't feel that bad about wrong answers. So okay, so then that case I just do if key is in sub.cache, then we just update it, and then we return. We might let's just leave a note. We might have to update the last used list. And then otherwise, then this should be true. Um, yeah, but I'm not. I mean, if this was a contest, maybe I would try to come up with another example to show that this is the case. But okay, let's do that then. Why not? But the idea is that now, um, okay, let's just take this test case. It's very similar. Um, and now you update it, and then now when you put in another number, okay, actually what we can do is now we update the 2 instead. Um, the 2, and then now we update another number, say a 3, and then now let's see what the behavior is for 1, 2, 3. Okay, I might have missed something. Oh, I missed a get on the thing. That's why I don't like these bombs. Is that it's hard to test. That's all. Like, or it's hard to type in the Leetcode test. Um, okay, so from here we can see that our assumptions was wrong, or my assumption was wrong. When you do this update, um, you do update it. So okay, so let's do that. That's not that hard, right? Because we just have to do sub.link list dot move to back. And on the contest, this is actually going to be a little bit tricky to test because, well, they don't give you the right answer, right? At least not without throwing in a wrong answer for it. So that's all you really need. But I just wasn't sure from, like when you read this poem, it's not immediately clear, how to read all these things. But, oh, no, I have another one. So, okay, let's see what assumptions I made in this one. Okay, so you do 1, 2, 3, 4, 5, 1, 2, 3, 4. The 1 gets invalidated, so it should be 2, 3, and 4. You do 4, 3, 2, 1, that's fine. And then you put in a 5. That's 2 is the most recently used. 1 doesn't make sense. 2 is gone. Uh, did I do this? Because you get 2, 3, 4, but the 5 inserting the 5 should invalidate the 4, but I guess it doesn't. It invalidates the 2, even though I do definitely do get a get here. Uh, hmm. Let's take a look. Let me move to the back. I mean, it also might be just that I have a silly typo somewhere again, which is, it is what it is. Let's print this out just so I can be sure. Or actually, I could even do slightly better, which is let's just do a string method for debugging. Return. I guess I don't know if I could do an iterator that way, but let's just do. Hmm, oh yeah. Well, sub that's is not sub that sentinel. Debug dot pen current dot route. Current is equal to current dot next, and just return. I don't know. Join debug, something like that. Current is equal to sub dot sentinel dot next. And now we can just do sub dot like this on the get. It fell. Oh, did I? Oops. There you have that. Oh yeah, I have a lot of stuff. So let's get rid of some of the other previous cases first for now. And then we'll bring it back in a second. Okay. Why are there so many empty spaces? It's actually a little bit discerning. Maybe that's why my linked list is a little bit weird. But okay, let's also print it out. Yeah, I don't know why there's so many empty in this. So I think maybe that's why. Maybe that, I mean, I am trying to do a little bit of learning on how to do Sentinel value stuff, linked list. So bear with me. So okay, so the first get is a 4, but 4 should be in the back. That's fine, and then we should move 3 to the back, and then we should move 2 to the back. But then now we lost the linked list. So to move to the back has a bug somewhere. Let's think about it again. Okay, the node is this node. The node's previous node. That next is node that next. That node. Okay, so this seems okay. Then now we want to move to the back. Also, let's just for the purpose, I think we can actually move to back. Well, yeah. So the sentinels. So the previous tail, that next is going to be the node. That's reasonable. Let's put these together for real quick. And then the tail points to the node. Is that right? Now, yeah, okay. Now this is right. Maybe. And node that next is a sentinel. That makes sense. These two are together. And then node that previous is self that. Okay, this is wrong. Or this is not wrong, but it's in the wrong order. Yeah, okay. So these things have to be careful. And really, what I should have done is use a temporary variable so that it's really easier to debug this. But okay, node that previous that next is. If this is a new node, then yeah, then the previous is going to be none. Then you don't do this. Okay, well. So then you have to do some test case anyway. So I don't know. I think maybe I prematurely optimize certain parts, but that's okay. It's not that premature, I suppose. Okay, it's still wrong-ish. Uh, huh. As I point out in the case, we still don't have to. I still have it right in the right order. Uh, this could be last. That's fine. Self dot center x. So yeah, the previous node points to here. That's okay. This is okay. Whenever previous is equal to send dot previous. Yeah, that looks okay too. So why am I getting this here? Why is it that when I move the 2 to the back, it goes bye-bye to the thing? Uh, hmm. Oh, well, this is a very debuggy centrally thing. Okay, so move 1 to the back. Okay, 2, 3, 4, and then 4 again, and then 3. That seems okay, but a 2 is where it all goes wrong. Did I set up? I mean, I could also have set up the other stuff incorrectly before. So now, well, push is just the only way to do this. So we push a new no, looks okay. And then self.send is so the beginning of the linked list still points at 2, right? But that's part of. Uh, this should not be no. So this should be sentinel. So why is that not triggering correctly? Hmm. Hmm. That's 2. That's fine. But the previous is 1. Huh. I think there's something wrong with my pop front then. It's not popping correctly. Because, ow, oh, what a silly typo. Sometimes I name them previous and not prev. Uh-huh. Okay. Okay. All right. All right. All right. So that is one advantage of typed language is you probably wouldn't run into that. But with untyped language, it's a dynamic language. Well, not typed in this case. It's easy to have a typo and then it. Okay, well, sad face. All right, let's run it again. Okay, are these right answers? I can't really tell. Okay, I'll show diff. All right, let's submit again then. Okay, cool. Okay. I mean, there were I think there was one real bug in that I missed. I think I just wrote self dot send. I think this one I just forgot to put dot previous or something. And here was just another big typo that we missed. And there were a couple of typos, but which is a little bit tricky. Which is why we have. This is why I always advocate unit testing. And on an interview, you might not or you might not have time to do unit testing. But I would at least while I'm typing it out, be like, okay. Ideally, I would have unit testing, and also if you have good, if you're able to talk about it well with your interviewer, they may point out typos like this, like where they're like, oh, by the way, you have a previous, and especially if they're paying attention, these are things that actually wouldn't take you as much time to debug. or at least maybe they let you struggle a little bit, but then they would just point it out later, because and that's also something that maybe the linter would catch in either case. But yeah, so this is all of one because, well, every operation here is all of one, or and space because you need multiple items per key. Um, but yeah, but I'm glad that I took the time to kind of learn how to do Sentinel values, and actually I did it mostly right, minus one thing where I just point the wrong, I just forgot to point to point next or something, and then the other one is yeah, no, I mean, I think mostly I did okay with learning this new technique. So thank you for watching and bearing it with me. Um, yeah, mostly I just had typos that were annoying to debug, especially given these test cases. And I was a little bit, to be honest, a little bit lazy to, for this particular problem to type out the example cases. On an interview, I would probably be less lazy, um, just because I don't know, the custom test case is very hard, or like really weird to put in because if I was on an interview and I would talk about unit testing and testing, I would actually just literally write something like I don't know, like someone like, oh, is he going to, was it LRU cache? And then I would write like test that put, and then I would like start. I would actually make the effort to make these test cases and stuff like that. Uh, but yeah, and it would pay off because it's just that here for a little bit for the sake of time, I'm okay with taking some wrong answers because uh, I know that my algorithm is right and my timing is right. It's just that that's the point of testing in a way. And for me, mentally, I want to get that correct. Instead, I'm using that testing explicitly versus like taking the labor to write my own testing. But otherwise, yeah, this is a very standard problem, and I took probably way too long to do it. But I learned a new technique that I've been meaning to learn and practice it with the Sentinel versus just using nuns everywhere. Though that I still have nuns. Maybe I have to change that a little bit. Well, this is because there's a new node versus nodes that are already in the linked list. But yeah, overall, definitely a problem that I've seen multiple times. So definitely something that is highly recommended you practice and work on. Both, if nothing else, I have implemented this a few times, and I've a few times where the answer to some trivia question was LRU cache. So it's something that's very important, very easy to understand if you practice it enough. So definitely recommend it. That's what I have for today. It's been a long kind of problem, but I don't think it's not that hard. It's not that confusing. Feel free to ask questions if you have any. Let me know how you feel. How did you solve this problem? And yeah, let me know. And hopefully tomorrow will be an interesting problem, and we'll discuss some more. Have a good night. Bye bye.